Hello, students. This is Saxon Algebra 2, Lesson 77B, called Multiple Radicals. Multiple radicals means that there will be more than one radical expression in the equation. That's the new twist. And in this video, I will demonstrate how to cope with these equations by working through the example. We've learned how to solve radical equations like this one. Basically, you isolate, square, and simplify. You isolate the radical, and then you square both sides, and then you keep simplifying until you come up with a solution. Well, when you have an equation with more than one radical, you start out basically the same way. Isolate, square, simplify. It's best to isolate the radical with the most going on under the radical sign, which in this case is this one. This one has k minus 5 going on, whereas this one only has k going on. So we're going to isolate that one. That's the one we're going to choose to isolate. And so when we do that, we end up with this. We end up with the square root of k minus 5, I'm going to equals, because I'm isolating it. Now I have to add minus the square root of k to both. I have to add the square root of k to both sides. So there we go. And I have to subtract 1 from both sides. So I have isolated that radical. The next step is to square both sides. And so I'm going to square both sides. And of course, with this one, we just come out with k minus 5. But with this one, oh, that looks a little daunting. But we know how to deal with radical signs. We may never have squared them like this before, but doesn't mean we don't know how. So the square root of k times the square root of k is k. The square root of k times minus 1 is minus the square root of k. Minus 1 times the square root of k is another minus the square root of k. And minus 1 times minus 1 is plus 1. So we find that this side of the equation is k minus 2 square roots of k plus 1. And this side of the equation was still k minus 5. And here we see that we have k on both sides of the equation. So we can just go ahead and subtract k from both sides of the equation. And now I'm not really fond of working with a minus 2 square roots of k. So I'm going to bring everything over to the left side of the equation by adding 2 square roots of k to both sides and subtracting 1 from both sides. And there was already a 5 over there. So now we have the 2 square roots of k minus 1 minus 5 equals 0. And I'm going to simplify before I go on. 2 square roots of k minus 6 equals 0. Well, here we are again. We know that looks very familiar to us. Now, we may have never seen a coefficient in front of the radical, but we've seen other coefficients, and so they're not scary. And so we go back up here to isolate, square, simplify. This time I'm going to be isolating this one because it's the only one I have. So when I isolate that one, I'm going to end up with 2 square roots of k equals 6. I'm going to divide both sides by 2 and get the square root of k equals 3. And then I'm going to square both sides so that I can get a value for k. K equals 9. Now, it would seem like I have solved that problem and I'm finished. But remember, we're never finished until we plug it back into the original equation and see if it fits. So the original equation was the square root of k, which we think is 9 minus 5, minus the square root of k, which we think is 9, plus 1 equals 0. And we work this out. 9 minus 5 is 4, and the square root of 9 is 3. And so we have square root of 4 is 2 minus 3 plus 1. That should be 0 equals 0. Let's see, 2 minus 3 is minus 1 plus 1 is 0. Yes. So it has been proven true. So I just want to review for you the algorithm that you would use to solve an equation with multiple with multiple radicals. First of all, you would isolate the radical. If there's more than one, you take the messiest radical and isolate that one first. And then you square both sides, and then you simplify, and then you come to a decision point. Are there any more radicals? If the answer is yes, then you go back up to isolate, and then you go down to square and simplify. Are there any more radicals? As long as there's a yes, you just keep going through that loop and until you get to the point where there are no more radicals. And then many students think they're done at this point. Remember that you are not done. You are ready to plug in to the original equation. And then you're done. So I hope this video helped you to understand the concept of multiple radicals and how to work through them. And I'll see you again.